Hello, fourth grade students. This is Jason Brown, Boone County 4-H, coming to you with a pre-recorded lesson for our Force in Motion lesson. Now, obviously, if we were in the classroom, we'd do this lesson live, and being able to interact with you would be a whole lot more fun, but obviously that's not the case for right now, and so hopefully this lesson will be something that you'll enjoy. I will say, having pre-recorded it, I was able to contribute some videos in the lesson that I hope that you'll enjoy and will be good examples that we might not have been able to do if we actually had this in class. So hopefully that'll help a little bit make the lesson a little more enjoyable because we are separated at this point with our social distancing. So let's dive in. Let's talk about force and motion. The first thing we're going to address is something that's really simple. You don't need a high sort of level of academic ability. You don't need to love science to understand this, and that is position and motion. What's position? It's simply the place an object holds, okay? If you're at home and you're looking at your Chromebook while you watch this lesson, the place your Chromebook is sitting, that's its position, the place that object holds. And the same term, motion, is another term we're looking at, and that's just simply a change in position of that object. So if you decided sitting at the table is a bit uncomfortable, I'm going to take my Chromebook and go sit on the couch, and you pick up the Chromebook and carry it over and set it in your lap on the couch so you can be nice and comfortable. That's a change in position, and that's motion, okay? And so, simple stuff. What causes this change in position? A force, okay? So all motion is due to forces acting on objects. What is a force? It's a push or a pull action that impacts an object and causes it to move. And so it's important to kind of understand that when we look at force and motion, a force is that thing that causes that change in position or causes that object to go into motion. If you pick your Chromebook up and carry it over, what is the force? You, okay? And you're pulling or picking up and carrying your Chromebook over to the couch. Okay, a great example is my pug here, Clara. She has a position. That's the place she holds there. And we're going to see in a minute, motion, a change in position. Watch it in slow motion. She has a position, and then motion is that change in position as you see her take off. So now we're going to look at Newton's 3 laws of motion, okay? I would assume all of you know who Isaac Newton is, the English scientist who came up with these laws related to force and motion. There's the legendary story about him sitting under an apple tree, and an apple fell off and hit him on the head, and that made him begin to think about things related to gravity as a force. Well, that's a wonderful story, but most likely he had those ideas and concepts in mind way before this apple fell on his head. But we do know him as a great scientist and someone that we've learned a lot from in the area of force and motion. So what we're going to do is we're going to go through and look at these 3 laws. The first one, first law of motion, an object at rest will stay at rest unless a force acts upon it. An object in motion will stay in motion unless a force acts upon it. And then the second one there, second law of motion, motion is produced when force acts upon an object. The greater the size of an object being moved, the greater the amount of force needed to move it. Then the third one, for every action, there's an equal and opposite reaction. So let's look individually at these 3 laws. Okay, so Newton's first law of motion, an object at rest will stay at rest unless a force acts upon it. An object in motion will stay in motion unless a force acts upon it. So at the very base foundation of what this law says is that an object in its position will remain in that position forever unless a force acts upon it. So a very simple example, we talked about your Chromebook. Your Chromebook should, based on this law, at its sort of foundational understanding, if you left it there on the table, would sit there literally forever unless there's a force that acts upon it. Now, let's watch some videos and get some examples of both of these. An object at rest, the fact that it would stay at rest forever in that position if a force didn't act upon it. And we're also going to look at an object in motion and a force acting upon it. Object in motion, as an example, will stay in motion in the same direction unless a force acts upon it. It's exactly what Claire is doing right there in the video. Slow motion. Object in motion, according to Newton's first law, will travel in that same direction forever, but here comes a force to act upon it. Clara, demonstrating Newton's first law there. Here's my cat Max demonstrating Newton's first law of motion. An object at rest will stay at rest. Oh, unless a force acts upon it. Let's watch it in slow motion. An object at rest stays at rest unless a force acts upon it. There's Max demonstrating Newton's first law of motion. Okay, Newton's second law of motion says motion is produced when force acts upon an object. The greater the size of an object being moved, the greater amount of force needed to move that object. That's pretty simple too. If you go to move your pencil, that's really easy. Doesn't take a lot of force to move it. If you move your Chromebook, going to take a little more force to do that. Say you have pets at home like I do. You know, Clara weighs a lot more than Max. So if I had to pick Clara up, I'm going to have to use a lot more force to pick Clara up, because she's like a giant bowling ball, than I would Max, who's just a smaller cat. And so that's an example, and maybe you could think of your own pets at home as well. Let's look at a couple of other cool examples. Okay, so in this example we're looking at, we are moving cars, pushing cars. I'm applying a force to this very tiny car, the Matchbox car. It doesn't take a lot of force, but if I were to try to move a large car like this one, my car, it'd take a whole lot more force to get that to move. Yes, my parking brake is on because I didn't want to chase my car over the hill, but hopefully you get the idea. Okay, Newton's third law of motion. For every action, there's an equal and opposite reaction. There are times in your life where the force that you apply to something, there's an equal force pushing back. You see in the picture there on the right of the people standing on the beach, that's a perfect example. The ground applies a force back on your feet that's the exact same as your footing. Otherwise, you'd crash through the sand there to the next layer. And so there's a force pushing up. You see the tug-of-war game going on there. If both sides are applying the same amount of pull force, then they're not going to go anywhere, are they? Okay, because it's an equal and opposite reaction. By the way, just so you know, Newton's is just a measurement of force, and just sort of references how much force is needed to move an object. Not something we'll focus on a lot, but it is something that you would want to know since it's listed there. There are obvious exceptions to Newton's third law, and you probably could have guessed this, and they're called unbalanced forces. If one of the forces being applied is greater than the other, it can cause a change in position of the weaker force. Let's go back to our tug-of-war game going on. If the one side is applying 40 newtons as far as that much force, and the other side's only applying 25, which group is going to pull? They've created an unbalanced force, and so you can see. And of course, winning tug-of-war is all about creating an unbalanced force and sort of outdoing the people on the other side. Only an unbalanced force can change the motion of an object. Okay? If you have two cars collide and one's bigger than the other, that bigger vehicle can often cause the smaller vehicle to change its direction or deflect off because it's an unbalanced force that's happening. Or if the one vehicle is going faster than the other vehicle, that can cause an unbalanced force. Great example, your dog. Maybe you've got a real big dog and your parents tell you to take that dog out and take it for a walk, and that dog, it just pulls you most of the time because his force that he's applying is greater than your ability to stay in place and walk nice and slowly on your walk instead of having to run to chase and keep up with him who's all excited. So with those three laws of motion and force in mind, let's talk about types of forces. There are lots of types of forces that exist in our world. We've already talked about some of those forces, everything from Clara on up to us as humans moving Chromebooks and things like that. But there are other types of forces that generally we want to look at. And it says on our slide here, forces change the way objects move. They can make an object move faster or slower, or they can change the object's direction or shape. You cannot see these forces. You can only feel their effects. So let's look at some of these forces that we're going to mention. So let's talk about gravity. We all know what gravity is. It's that force that pulls objects back down to the surface and helps hold objects to the surface. And we all know the further from the Earth's surface we travel, the weaker that force becomes. And gravity has an impact on how much energy is needed to move an object. And so there's, multiples of things and examples we can come up with of how gravity impacts our everyday lives. So I could ask you the question, have you ever been on a long hike and become tired? Well, gravity is a big factor in your fatigue. Each step is resisted by the force of gravity. And the longer you take that hike and you lift your feet and your legs to move, the more that gravity is going to start to have an impact because you, as that force, have a finite amount of energy. And so you will start to run out of energy and your ability to fight against the force of gravity will become less. Have you ever thrown a ball and you were sure it would travel far, but it fell short of your target? Well, gravity is a big factor in why the ball didn't travel as far. And even though you don't think at that moment in the big game to blame gravity, next time you throw the ball, you'll know you need to throw it with greater force. And so that's another pretty good example of gravity and how it impacts us in our lives. Let's go back to Max. When Max knocks the cat toy off the table, gravity pulls it to the ground. Now, if there's no gravity, Newton's law would say as soon as he bumps it and knocks it forward, it should travel forward in the same direction and not fall to the ground. So friction is another force. When two objects rub up against each other, this force can cause objects to hold better to each other. And friction can impact motion. Greater the friction, the slower the object will go, and the greater force needed to move that object farther. And we can point out loads of examples of times in which friction is really a great thing and very helpful. So let's look at a couple of examples. Have you ever been with your parents as they drive in the snow? I think we're a pretty good ways off from snow. It's just early, kind of late summer, early fall. Snow might be coming, and friction is a big factor in the ability for the tires to hold onto a slick road. The tread on the tires cause a greater level of friction. Maybe your parents have put off buying tires and maybe the tread's not so great on them, and a lot of people do that. It happens, but maybe there's not as much tread and the snow comes and they're not going to have as much friction because they don't have some good tread on those tires, and that can cause some slipping and sliding, okay? You want friction when it comes to driving in the snow. You want friction when it comes to walking on the sidewalk when you leave school and it's snowing, things like that. Friction can be good for those reasons. Friction can be something you don't want a lot of. Again, let's go back to snow. I would bet you've been snow sledding. Friction is less welcome if you're sledding. You want a smooth bottom of the sled for greater speed. And also, you've probably noticed that if you went sledding, the first few times you go down the hill, not as fast, but as you pack down and smooth out that snow, you pick up speed because there's less friction, and that's when it gets a lot more fun. So as we said, there's several examples of why friction is good, and sometimes it's not so good. Okay, an example of friction here is I've been doing some work on my house and trying to work on a wall here, and sandpaper sponges, of course, sandpaper has a lot of friction there because they've got that rough edge, or rough surface. And it can be used, friction can be used to sort of work and smooth out the surface after you've done some mudding to a wall. I know it's something you might not be familiar with, but you can obviously see in the video that the friction I'm creating by pressing the sandpaper is causing a lot of that filler to be sanded off so it can be smoothed out. So it's a great example of friction taking place there. Another force is natural forces. These are forces that come from the natural processes of the earth. Forces such as rain, wind, earthquakes, and other natural forces can move objects. Okay? Now, some natural forces are pretty easy to understand and see. We've had a lot of hurricane activity and tropical storm activity on the coast, and when those winds come through and water, the damage is clear to see. And so that's pretty easy to understand that there are forces in our world, natural forces, that can cause a lot of force and create quite a bit of motion. That being said, even something as simple as raindrops, as you see here, look how high the water is rising when the droplet hits there. And that shows very clearly that Quite a bit of natural force can even happen with raindrops because as they hit and explode, that's moving particles around. Even if it's not on a large scale like a hurricane, you still see that activity happening. Elastic forces. Okay, some forces cause an object to give, and once that force is absorbed, it returns to its original shape. And there are many elastic forces in our world. You know, rubber balls, sports shoes, even our skin is an elastic force. But look around and you'll see a lot of elastic forces in our world. If you wear tennis shoes, every time you take a step, that tennis shoe, that rubber foam kind of smashes, absorbs that energy, and then when you take that step forward, it then returns to its original shape. And what that does is that deflects the ground, the impact of the ground away from your foot, and your feet don't hurt. Okay, so there's a lot of elastic forces in our world. Cars, new cars have these bumpers that are meant to absorb the shock of an impact so that once that force is absorbed, it's deflected away from the people in the car. And that's another great example. Great example of an elastic force. This lady's using a giant rubber band to exercise. She's pulling on that elastic, and when she bends over, it goes back to its original shape there. This young lady here, she is showing us that our skin is an elastic force. Look how she's causing her cheeks to bulge out and smushing them, showing that our skin is an elastic force. Mechanical forces. These are forces that are produced by people or machines. Machines have a greater ability to produce motion or change than what a human could do. And so there's a lot of mechanical things we use in our world that helps us out a lot. Like if you're back in class already, maybe in your classroom you have an electric pencil sharpener, sharpens a pencil a lot faster than the hand crank pencil sharpener. Maybe you have one of those in your class. Okay, so have you ever been on a trip to Florida? Maybe last summer you took a trip to Florida. Maybe this summer you were able to safely go on a trip to Florida and get some family time in and still social distance. And if you did, think about the mechanical force that is your parents' vehicle, which will get you to Florida, to the beach, in 12 hours. Now, if you used a bike, which is a mechanical force powered by human effort, that trip could take 3 days. And that's 3 days if you don't stop, and that's 3 days probably assuming that the ground is perfectly flat and it's easy going as far as biking. So you can see how a mechanical force, like a car, great advantage when it comes to travel and using less human energy. So that's the lesson on force and motion. Hopefully you learned a lot and it helped you out. A lot of that stuff we talked about today you probably already know because you've either been taught it already or it's just common sense. But it is good to go back and review some of those things. I do want to tell you about our newsletter. If you haven't heard yet, each month we're going to send a link to the teacher so you can view the electronic 4-H newsletter. Now, if you don't get that link, it's simple. Just go to the description at the bottom here, click on the link, just like the one you'll see here in this slide, and you'll be able to look at that and look at the newsletter. Our newsletter is the best way to keep up with enrollment deadlines, dates, information about 4-H camp, information about 4-H clubs, and summer projects. So it's really get that newsletter and look at it so you know what's going on. I highly recommend that. 4-H enrollment. 4-H enrollment is free, okay? So we want to let you know that right up front. The first and best way to begin your 4-H experience is to enroll. Check it out. Again, there's the link. I will put that same link down in the description below. And you know, even if you're not currently interested in 4-H programming, I would recommend you enroll anyway because it's free, it's simple, doesn't take a lot of time. And the reason to do it is because a lot of times there are deadlines for certain programs. And if you have to go through the process of enrolling and then signing up for a program, sometimes you'll miss it. So if you're already enrolled and that program comes along, all you have to do is jump on board, have your parents sign you up for it, you're done. So I highly recommend that you enroll and go ahead and make that happen now. Again, Jason Brown, Boone County 4-H. If you want to talk to me about something related to our programs with 4-H, have your parents email me or call me at the office. I'd be more than happy to talk to you about the things that we do and the things we can offer. We can even offer a lot of things during this social distancing COVID time, And so there are a lot of things we still have going on and we can offer, and I really hope that you'll be able to be a part of that and be able to join us. If not, I will talk to you some way, somehow, very soon with our next lesson. Hope everybody has a great day.